Good morning, everyone, and welcome to this special lecture. We are into lecture number 7 of SHM, and most likely we would be winding up your SHM in this particular class. Well, just to give you a quick recap of what we had done in the previous class. In the previous class, we had seen some really nice problems where we had found out the what the amplitude of SHM in different cases, and we had found out once you know the amplitude, you can easily calculate. You can easily calculate what everything that can be asked in SHM once you know the amplitude, and we had seen how we are going to calculate the amplitude in various cases. We had also seen a very peculiar case where what where non-conservative force were present, friction was there, but still the motion was simple harmonic, because of the simple reason that the frictional force was not doing any work. Work done by that non-conservative force was zero, so mechanical energy was conserved. Case of pure rolling, the friction is there, but mechanical energy is conserved, because in pure rolling, friction does not do any work, unless we'll talk about rolling friction, which is not in our course. The last thing that we had done was we were looking at the combination of spring. So let us quickly go through this combination. The first combination of the spring is known as the series combination. In series combination, the first thing that you should always remember is the extensions or the compression in both the springs, or if there are more springs, compression or extension in the springs are different, but the force which acts on all the springs, because springs are massless, the force that acts on all the springs is same. Do we understand this? Yes or no?
Yes, sir.
So we can write this equation from there. Force acting on each spring K1 x1 will be equal to K2 x2 will be equal to K effective into x. The other equation that we must remember is x1 plus x2 is the total x. Now, from this equation only, the third equation, this equation has come, because I can write x as f by k effective. I can write x1 as f by k1, and I can write x2 as f by k2, and that is how we arrive at this equation, which tells us the effective spring constant of the springs which are connected in this way in series. The omega in this case, how does it change? Well, in place of k, spring constant of one spring, we put k effective, where k effective is the spring constant of all the springs put together. Do we remember this now? Now that was what? That was the series
Series
combination
combination
of
of
springs.
springs.
Now, so in series combination, and the series combination of spring is something same as what we are going to see in your chapter on electric current or capacitance. The series combination of springs is exactly similar to what? Exactly similar to what? The series combination of springs is exactly similar to what? Amitabh Bachchan?
Capacitance, sir.
Series or parallel combination of capacitance, series or parallel combination of resistance, or any other thing. So, since one combination is known as series, the other combination would be known as
Parallel.
parallel combination. Now, what we see in series combination, in parallel combination, we see the exact opposite or reverse. What do you mean by exact opposite or reverse? Huh? What do you mean by exact opposite or reverse?
Means addition, summation of ki.
Addition, summation of ki, whatever. if I connect two springs like this, and if I displace this mass by x, if I move this mass by x, what will be the displacement or extension in both of the strings? The displacement in both of the strings would be x and x. Yes or no?
Yes, sir.
So here what you have to remember in this type of combination, x is same. The extension in all the springs is same, but forces acting on the springs is different. Do we understand this? X, the extension or the compression, of the springs is same, but the forces acting on the spring is different. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
Bye bye, sir. I'm going, sir. So it is exactly reverse of this. Now, whether the springs are connected like this, what type of combination would be this one? The springs are connected in this fashion.
Parallel.
This one.
Parallel, sir.
Why parallel, sir?
Displacement is same, but forces are different.
Do we understand this? Or it is going above our head saying bye bye? Bye bye, bye bye. Anyone is able to understand this?
Yes, sir.
Boys and girls. What about this one?
That is also same, sir. Parallel.
So in all the three cases, as you can see, the extension in the springs would be same. The forces acting on the springs would be different, and therefore all of these three are nothing but parallel combination. Parallel combination. Parallel combination. So what do we have? If I say that the total force, and I will draw here total force, the total force acting on this block. Now when I pull the block downwards, force acting on the block will be upwards. Yes or no? No, yes.
Yes, sir.
If I say that the force acting on this block is F1 force will be coming from this spring, and F2 force would be coming from this spring. Yes or no?
Yes, sir.
So from here I can write what I can write. Total force F acting on the block will be equal to F1 plus F2. Yes or no?
Yes, sir.
But the displacement is same. Now, this F can be written as K effective multiplied by X. This will again be equal to what the hell? Things happen sometimes and we have no control about them. So what do? You take a deep breath and write it again. So this F could be written as K effective multiplied by X. This will again be equal to K1 multiplied by X. This would again be equal to K2 multiplied by X. What I am writing here? I lost my thing. F can be written as K effective multiplied by X. F1 can be written as K1 multiplied by X. F2 can be written as K2 multiplied by X. Now if I put these things, oh, what I have shared. Okay. So, do we understand what I'm writing here? Everyone is there or not?
Yes, sir.
Okay. So, I can write F as K effective multiplied by X, F1 as K1 multiplied by X, F2 as K2 multiplied by X. I can put them in this equation. Which equation I'm talking about? This equation I will get the formula that I was looking for. K effective will be summation of Ki. And I can write omega is equal to root over K effective divided by M. We understand this, everyone?
Yes, sir.
This is what we call the parallel combination of two springs. I'll give you 2 minutes to note this down. Everyone has understood this?
Yes, sir.
I'll give you 2 minutes to note it down. And then we will solve some questions and move on to the next topic. Do it fast.
Completed, sir.
Done? Good. Then you can do a couple of problems on this. I think that would be good enough for you to understand this. This is the first problem. This is the problem. One body is suspended from a spring of length L, spring constant K, and a time period T. Now, if the spring is divided into two equal parts which are joined in parallel, and the same body is suspended from the arrangement, what would be the time period? We have to give the answer in terms of the original time period. You understand this question?
Yes, sir.
I'll give you 2 minutes to do this. So how are you supposed to do this? In original case, time period is 3 pi root over m by k. Yes or no?
Yes, sir.
Now, what is the new time period? Now, what has happened is I divided it into two equal halves. When I divide the spring into two equal halves, I will get two springs. What will be the spring constant of those two springs?
2K and 2K, sir.
2k and 2k, and that 2k and 2k are connected in parallel. Yes or no? So the effective spring constant will become 4 times k. So that becomes your next, the new time period T1, and you can find out the relation between T1 and T2. Do we understand this? Yes or no? No, yes.
Yes, sir.
Pakka, everyone understands this?
Yes, sir.
Okay. Give you one more question on this, I think. I have one more question. Probably we'll give you that. And then we can move ahead. Where is that question? This one. Question number 2. Question is pretty simple. I'll give you 1 minute to give me the answer. The answer is also pretty simple. Yes. So we got the answer in first case. We have to find out the ratio of frequency. Remember omega. We have to find out frequency F. So remember the ratio 1:2 or T:1. In this case, the effective spring constant becomes K by 2. In this case, it becomes 2K. Yes or no?
Yes, sir.
Frequency means F. And this is 1 by 2 pi root over K by M. Yes or no?
Yes, sir.
So F is directly proportional to K. So I can get F1 by F2 will be equal to K by 2 divided by 2K. So the answer is, sorry, it has to be root over this. So the answer is root over this. So the answer is 1 by 2. Remember the way in which the question is asked and the ratio that is asked. If the ratio of time period, it will be it will be proportional to root over m by k. But frequency or angular frequency will be proportional to root over k by m. Everyone understands this? Yes or no? No, yes.
Understood, sir.
Pakka?
Yes, sir.
Okay. Then let us move ahead. Then let us move ahead and move on to the next thing. And what is the next thing that we are supposed to do? The next thing that we are supposed to do is known as angular SHM. Next thing that we are supposed to do is what we call as angular SHM. What do you mean by angular SHM, my dear friends? What do you mean by angular SHM, my dear friends? Yes. No idea? Angular SHM, my dear friends? Abhi tak we were doing SHM in a straight line. Now we are going to do angular SHM. What do you mean by angular SHM? And the simple example, no idea angular SHM?
Sir, we can take an example of bob and a string.
Bob and a string, that is known as a simple pendulum. We can take the example of a simple pendulum. What happens in a simple pendulum? You have a string of length L and mass M, and a string of length L and a bob of mass M is attached to the end of the string. And then if you just take it to some height and leave it, you take it to some height and leave it. Let us say I take it to this angle theta naught and leave it. If this angle is small, you can see that this bob is going to execute very closely simple harmonic motion. Now this type of simple harmonic motion where the body is moving in a circular path or rotating about a point, that is known as your angular SHM. Do we understand this, or this has gone above our head saying bye bye? Bye bye.
Understood, sir.
Bye bye. Bye bye. Bye bye. Now, in this angular SHM, now this angular SHM is exactly the counterpart of linear SHM. How it is a counterpart of linear SHM. Now, we'll just try to compare the equations of angular SHM and equations of linear SHM. So we will understand the relation between angular SHM and linear SHM. So what I'm going to do is I'm going to write the linear SHM here. Now once you understand, and then we will write the angular SHM here. Now, first things first, in linear SHM, how did I start linear SHM? I said the force must be proportional to, very clearly, let me write it as minus x. Yes or no? Huh?
Yes, sir.
For proving any SHM as a linear SHM, I had to prove that it has a force which is proportional to minus x, where x is the displacement from the mean position. Yes or no?
Yes, sir.
Here, what will I do? I will find the torque and will be taken proportional to minus theta, where theta is the angular displacement from the mean position. So there would be a mean position, and in this case the mean position is here. Do we understand this?
Yes, sir.
Equation number 2. So I can write this force is equal to minus kx, where x becomes your force constant. Here you can write tau is equal to minus k theta. Instead of writing it as k, because you cannot use k, c theta. The C becomes the torque constant, or sometimes we call it torsional spring constant. You understand this? Yes or no? No or yes? Huh?
Yes.
Third, now the acceleration becomes minus k by m, minus sign only indicating that it is opposite to displacement. Here what will you get? Say, only photocopying everything. What will you get here?
Angular acceleration is equals to minus c theta by m.
Shabash. Congratulations on your great reply. Angular acceleration will be equal to minus c by m. Okay, I'll write it. Well done. See, it was so difficult. Minus c by m.
Sir, theta.
Huh?
Theta కూడా చెప్పిన
What?
మైనస్ సి theta by m అని చెప్పినాను.
Yes? Say.
Nothing, sir.
Correct, no? Okay. So instead of writing angular acceleration as alpha, I am going to write it as this theta double dot. This one dot means derivative of theta, two dot means the second derivative of theta. So your second derivative of theta, which is alpha, angular acceleration will be written as c by m. We understand this, everyone? Yes or no? See, so good. I'm so proud of you. See, in linear motion we had x. In angular motion we had angular displacement. In translational motion we have f. In rotational motion we have torque. See how much I'm so proud of you. For translational motion we have acceleration. For rotational motion we have angular acceleration. See, so simple. For translational motion we have m, and for rotational motion we also have m. We have I. Okay, there is no point of me giving any philosophical lectures because it is of no use. Okay, so next one. When we solve the equation of this, I will get the value of x, and x will be written as a sine omega t plus phi, the most general equation. Here I can write the same equation in this form. How will I write the same equation here? Let's not waste time. I don't have time to waste. Theta dot, I'm not writing it as omega because, okay, let me not write this equation here first. Let me write the value of omega. Omega, the angular frequency of this, is given by root over k by m. Here also the omega, the angular frequency, is written by root over c by I. Since I am using omega here for angular velocity and angular acceleration, I will use theta dot and theta double dot. Number 5, x is equal to a sine omega t plus, let me write it as phi. So how will I write it? Theta will be equal to theta naught. Theta naught is the angular amplitude. Sine of omega t plus phi. Sixth one, I differentiate this equation. I get the value of velocity v. V is equal to a omega cos of omega t plus phi. Here I will get theta dot is equal to theta naught into omega into sine of omega t plus phi.
Sir, cos or sin?
Cos. Chalo, we at least remember that the derivative of sine is cos. We don't remember that in a rotational mass, because mass does not do anything, is the moment of inertia who does. We don't remember that. We have forgotten rotation. Rotation gone, rotation come, rotation gone. Yeah, I mean, if you would have told me I, then I would be surprised. You told me M, I knew that you are going to say M. That is why I stopped. I knew that you are going to say M. I know that you will say M. That is why I stopped. Huh. This is V in terms of time. I can also write V in terms of omega into root over a square minus x square. Similarly, here also I can write the same thing. What will be the formula here? Huh? How do I know, sir? You ask anything, sir? How do I know, sir? Theta dot will be equal to omega into root over theta naught square minus theta square. 8 I will give you time to write. I'm giving you time. Minus a omega square sine of omega t plus phi. Here I will have theta double dot is equal to minus theta naught omega square sine of omega t plus phi. I'll give you 5 minutes. Note this down, aram se, and remember them. So these are the equations. As you can see, all the equations are exactly same. You just have to be careful while using these equations. Do you understand this, everyone? Yes or no?
Yes, sir.
Okay. Now, using this equation, we can write the time period of this simple pendulum, and time period of this simple pendulum will come like this. Time period of this simple pendulum will come like this: 2 pi root over L by G. So remember this, the time period will come by this, and omega will come as root over G by L. You know this, yes or no?
Yes, sir.
So write this, the time period of this pendulum. Now again, this motion is only simple harmonic if amplitude is very small. Okay, so we'll write some important points about this. Have you noted this down, everyone?
Yes, sir.
Ah,
Yes, sir.
okay. Now you can write some important points. Number 1, the motion is SHM only for what? Small amplitudes. The motion is SHM only for small amplitudes, and only for small amplitudes you have this formula. Only for small amplitudes is this formula valid. If the amplitude becomes large, my dear friend, this formula is not valid. Do we understand this?
Yes, sir.
Pakka na, sir.
Yes, sir.
Hey, you are pakka, to I know. But pakka is useless. Okay, anyways. I should no longer comment on your kacha and pakka. I am disheartened. Now, if the amplitude is more, then the motion is definitely not simple harmonic. So you must remember that in that case, the time period is given by this formula. Now, this formula is actually not in your course, but this is just for your thing that if there is a question like this, then this is the formula that you must use. Do we understand it? Yes or no? No or yeah? Noted this down? Noting this down or chilling out everyone? Noted this down? Huh? Everyone is there in the class or everyone has gone?
Video is on only.
Are you, have you noted down this one? Time
Yes,
period?
sir.
Say na. Then, now, if the length of this pendulum, and this is a question that you must remember, if the length is comparable to the radius of earth, or when the length becomes very large, the value of g changes. Do we understand this? We cannot take g as constant, and therefore the formula looks like this. You should remember this and not forget this, whatever happens, my dear friend. Which you will not remember, I know, but still, this is my job to tell you, keep on telling you that you must remember certain things. You might not remember, that's a different issue altogether. Okay, note it down. Have you noted down?
Yes, sir.
Say na.
Sir, I have said 2 minutes before, sir.
I have not heard it. This is the next one. If the pendulum becomes infinite in length, then the time period is given by 2 pi root over r by g, where r is the radius of earth. Where r is the radius of earth. Remember this. R is the radius of earth. All these things are worth remembering. There could be a question coming from this. Then we should be able to do them. R is the radius of earth. Next point. Sometimes we'll come across this one, which is known as a seconds pendulum, and we sometimes forget what is the time period of a seconds pendulum. Time period of a seconds pendulum is 2 seconds. So remember this. Time period of a seconds pendulum is 2 seconds. The next of the points are with regarding the change in time period, and this change in time period of a pendulum clock comes a lot of time. So if you have a clock which is based on simple pendulum, then the time period of that pendulum clock may increase or the time period of that pendulum clock may decrease. What will happen if the time period increases? The actual time period should be 2 seconds, but if it becomes 2.1 seconds, then what will happen?
Time runs slow, sir.
Yeah, so time will go slow. If the time period of the pendulum clock increases, the clock will go slow. So remember, the clock goes slow when the time period increases. Now, you can find out how much will be the change in time period, and this is a very, very important question for your JEE, because this question has come many times. So you can do it by error and measurement. Time period is proportional to root over L by G. So if you increase length, time period increases. If you decrease gravity, time period decreases, and you can find out the percentage change. Do we understand? This is known as a percentage change in the time, or time gained or time lost per second. Do we understand this? So you can find it out in this way. Everyone gets this? Change in time. Do we understand this, bacha?
Yes, sir.
Okay. Now, there could be a case where G remains constant. If G remains constant, you can eliminate that term of G, and then your formula will start to look like this. Then your formula will start to look like this. If G remains constant, time period will be proportional to change in length by original length, and if length remains constant, the formula starts to look like this. All these are questions that are going to arrive in your exam. I hope you understand the severity of this session. Huh?
Sir.
Nah. Must understand the severity of this session. This is just like the whatever the noted it down.
Yes, sir.
As I said, there are so many things in this chapter that are so much of exam material. This one, the graph. Oops. The graphs of t versus length versus time period, length versus time square, root of length versus this. They can give you any graph just to confuse you. Remember, time period is directly proportional to root over length, and hence we have all these graphs. This is time period. Do we understand these graphs? Yes or no? You're noting down? Note down the graphs for variation in G with variation in time period with G also. So the graphs are like this. I'll give you 2 minutes to note them down. Okay, so we have seen the variation in time period. Now you can also write the variation in time period due to temperature. Effect of temperature. Effect of temperature on the time period. Now, what is the effect of the temperature on the time period of a simple pendulum? When the temperature increases, the length increases. Yes or no?
Yes, sir.
When the length increases, the time period increases. Therefore, the clock becomes slow. Yes or no? Yes or no? So, this is the effect of temperature on this. When temperature increases, time period increase, when temperature increases, you can write it like this. When temperature increases, length of the pendulum increases, time period increases, and clock goes slow. Do we understand this? It starts to lose time, becomes slow. It starts to lose time. When temperature decreases, length of the pendulum decreases, time period decreases, and the clock goes fast. That implies it starts to gain time. How much time does it gain or lose? How much time that it gains or lose is given by half alpha delta theta. This is the time gained or lost per second. What is alpha? What is alpha here? Alpha
Angular
is
acceleration.
temperature coefficient of expansion. What has angular acceleration got to do here? Temperature coefficient of expansion, beta. That is what it is known as. Temperature coefficient of expansion. I'll give you 2 minutes to note it down. So this is what you must remember. Half alpha delta theta. Alpha is known as the temperature coefficient of expansion, linear expansion actually. It tells us how much the body expands with temperature. Now, what are the other things that you must remember about this time period? This time period of pendulum is independent of the mass of the bob. Do we understand this?
Yes, sir.
It does not depend on the mass of the bob. So, whatever be the mass of the bob, if you replace the bob with a heavier bob or a lighter bob, it does not make any difference whatsoever. It does not make any difference whatsoever because it is independent of mass of the bob. The next thing you must remember always, time period is proportional to root over L. That means it is directly proportional to root over length. And the most important thing, and which is going to make a lot of difference, time period is proportional to 1 by root over G. 1 by root over G, and this 1 by root over G makes a lot of difference. It depends on acceleration due to gravity, and this root over G makes a lot of difference because now, because it varies with root over G, it can become different in different cases. So what happens if your pendulum is in an accelerated frame? So that is the next heading that we will write. Time period in an accelerated frame. Time period of pendulum in an accelerated frame. Time period of a pendulum in an accelerated frame. Now, in an accelerated frame, you can find out the time period of the pendulum using this formula. You can find out the time period of a pendulum using this formula. Do we remember this formula, G effective?
Yes, sir.
Yes, sir, or no, sir? You can find out using this formula, G effective. Now you can see what? You can see the different cases, and you can find out the time period in those cases. Now, for example, you have this simple pendulum in a lift, and this lift is at rest. The lift is at rest or moving up and down with constant velocity. Then the time period of the pendulum in this lift will remain the original value. Time period will remain 2 pi root over L by G. Yes or no? No or yes? But if your lift now starts to move up with a constant acceleration A, then your time period will become accelerated frame. So you have to apply pseudo force in the downward direction. Remember pseudo force?
Yes, sir.
L upon G plus A. I hope you are able to understand this. Yes or no? No or yes?
Yes, sir.
If the lift now starts to move down, with a constant acceleration A, then your formula becomes 2 pi root over L by G minus A. If the lift is in free fall, you understand the meaning of free fall?
Yes, sir.
Somehow the the somehow the string, the pulley of that lift has snatched, and lift is moving down, falling under gravity. Then the time period will be infinite. That means the pendulum will not oscillate. Now, this is similar to the case when it is kept in a satellite or at the center of Earth where the value of G is 0. So remember all these cases, if a pendulum is taken to the center of Earth, G becomes 0. It will not oscillate. I hope you understand this. Yes or no? No, yes. Do we understand this? We understand this, beta?
Yes, sir.
Pakka? Okay. Have you noted it down? Note it down, beta? Note it down? Okay, I'll give you 2 minutes to note it down. So have you noted down the accelerate if it is an accelerated vehicle on a horizontal road, noted this down? Okay. Then you have one more case where the pendulum may be kept, which is this case. I have forgotten the number. Doesn't matter. If the pendulum is kept, whatever case is this, in a vehicle or a box which is moving down under gravity on an inclined plane, and I have the pendulum like this. Now, in this case also, you have a pendulum of mass m. In this case also, what you will have is you will have this pendulum in an accelerated frame. Yes or no? No, yes. Do we understand this?
Sir.
Now, what is the acceleration of this block downwards? We have seen that the acceleration of this block downwards, if it is under gravity, it is equal to g sine theta. Yes or no?
Yes, sir.
Now remember, in this case, if this is the vertical, this pendulum will not remain like this. The pendulum will be at an angle theta, and this at an angle, it will be inclined with the vertical at an angle. If I call this angle as phi, remember the angle phi will be same as angle theta, so it will become perpendicular like this. Do we understand what I'm saying? So this bob, when the thing is going down, will remain perpendicular. Do we understand? So it will remain at an angle with the vertical, which is same as the angle with the horizontal. Also remember here in this case, the omega is equal to g cos theta divided by L ka root. So time period in this case becomes 2 pi root over L by G effective. And in this case, the value of G effective will be coming as G cos theta. Do we understand this? Please note this down. Please note this down. I'll give you 2 minutes. Well, then the next case is if the simple pendulum is in a car which is moving on a circular track, all these are very interesting cases. And if this you understand the concept, and I hope you have understood the concept, the constant remains very simple, that somehow we need to find out the value of G effective. Do we understand this? Yes or no?
Yes, sir.
Somehow we need to just find out the value of G effective. In this case, the diagram looks like this, and we just have to find out the value of G effective, and the value of G effective will be G square plus V square by R ka square ka root. Yes or no? Do we understand this? This is perpendicular, this is coming here. I mean, this is parallel to the road. This is perpendicular, this comes here, and these two are at 90 degrees. So basically you are finding out 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 the effective value of G. In all these cases, we have just found out the effective value of G. Do we understand this, or this has gone above our head saying bye bye? Enough, sir, bye bye. Enough, sir, bye bye. Forgive us, sir, bye bye. Note it down
Yes, sir.
or chilling out. Okay. Now, sometimes you might have what? You might have, apart from gravity, other forces acting on it, on this pendulum. In that case, what we'll do? The concept remains same, but remember, this now we are not talking about an accelerated frame. We are talking about other forces acting on it. If other forces are acting on it, again we just have to find out the effective value of G, our own G, our lovely G. We have to find out the effective value of G, and once we get the effective value of G, once we get the effective value of G, we can have what? We can have the time period by effective value of G. For example, if your pendulum is oscillating, you don't have to write everything. If your pendulum is oscillating in a what? In a liquid of density rho, sorry, in a liquid of density sigma. So what will happen? Because of this pendulum being in liquid, it will experience an upward force, buoyant force. Yes or no? So your effective value of G, if you look at the effective value of G, your effective value of G will become weight minus buoyant force divided by weight minus buoyant force. Do we understand this?
Yes, sir.
So that is how you can find out this. So here, your value, don't have to write everything, just write the effective value of G becomes this much. So instead of G, you can just put the blue thing. You have to find out the effective weight in this case. Once you get the value of effective weight, getting the value of effective weight is basically getting the value of effective G. Once you get the value of effective G, you can find out, and if you want, you can remember this formula as well. Basically, you have to find out the value of effective G. I hope I have not confused you. I've tried to confuse you in many ways, but I'm trying to make you understand all types of questions that can come in a simple pendulum. Have you noted this down?
No, sir. 1 minute.
Okay, I'll give you 2 minutes. Then instead of upthrust, you can place this pendulum, give it a charge Q, and place it in an electric field. If the electric field is moving upwards, the upward force is QE. So your effective value of G, just draw the diagram and write the value of G. The effective value of G becomes G minus QE by M. Do we understand this? So in this case, my dear friends, your effective value of G will become G minus QE by M, and therefore your answer will become 2 pi root over L upon G minus QE by M. Everyone understands this, yes or no?
Yes, sir.
If your electric field would have been going downwards, then what would have happened? Again, this is same as lift. Instead of lift, what was happening in the lift was when the lift was going upwards, it was downwards. And when the lift was going downwards, it was upwards. Here it is not like that thing because it is not an accelerated frame. It is a different force acting on it. So whatever direction that force is acting, in that direction we have to apply the effective value of G. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Have you noted it down?
1 minute.
There are two cases. Here that you have to note down once when it is moving upwards with an acceleration, when the electric field is upwards, and when the electric field is downwards. Here also remember, this charge could be positive or negative. If the charge is positive, then it will experience force in the same direction. If the charge is negative, it will experience force in the opposite direction. So this is the next case where the electric field, in case of first case it was upwards, in the second case it is downwards. So now I'll give you 2 minutes. You can draw both the cases and note down their results. We are done with this, and let us quickly now solve some question and answer and solve them. And these are the questions that you are going to get in your examination hall. So this is the first one. It is based on coefficient of expansion. I've already given you the formula. I hope you can solve this question. A clock keeps correct time at 20 degrees Celsius. Now the temperature is changed to 40 degrees Celsius. If the coefficient of linear expansion of the pendulum is itna, how much will it lose or gain? Now, how are you supposed to solve this question? I will solve it for you. How we are supposed to do this? We know that delta t by t is half into alpha into delta theta. Do we understand this? We remember this formula, yes or no?
Yes,
Since
sir.
you don't know this term, that's why I'm doing it. This alpha is known as coefficient of linear
Linear
expansion. Do we understand this? This delta theta is the change in temperature. This delta theta is the change in temperature. So from this formula, I will get time. Will it gain time or will it lose time? Will it gain time or will it lose time?
Gain time.
Time gained. Well done, because the temperature has increased. Time gained per second. Per second, if I talk how much time it gains, that will be half into how much is alpha? 12 into 10 raised to the power minus 6. How much is the change in temperature? That is 40 minus 20, that is 20 degrees Celsius. So this is the time gained per second. Now you can find out time gained per day, and this is what is normally asked, how much time it gains per day. So per day, you multiply it by the number of seconds in one day, which is 86,400, and I think the answer will come somewhere around 10.3 seconds per day. So it will gain 10.3 seconds. It will go slower by 10.3 seconds in one day. Do we understand this? Yes or no? No or yes?
Yes, sir.
Have you understood this question, everyone? How is this question done?
Yes, sir.
Everyone got this? Can I have raised hands from everyone that we got this, sir? Have you noted it down, sir? Nah? Shall I move on to the next question, sir? Yes, sir or no, sir?
Yes, sir.
This is the next question, sir. Question number 2, sir. Same question are going to come in your exam, sir. The metallic bob of a simple pendulum has relative density rho. Relative density is density divided by density of water. Rho is number. You have heard about relative density, yes or no?
Yes, sir.
The metallic bob of a simple pendulum has relative density rho. If the time period of the pendulum is t, when the metallic bob is immersed in water, then what will be the new time period? So the bob is now immersed in water. These are very pet questions of JEE. Yes, my dear friends. Do we have any answer? Yes or no? No, yes. Anyone with an answer? We need time. Okay, I'll give you 2 minutes. Yes, it has to be D. T dash by T is root over rho upon rho minus sigma. Yes or no? Here, sigma is 1. Density of water is 1. And the density of that thing becomes 1 multiplied by rho. So instead of sigma, you just have to put rho. Instead of sigma, you just have to put 1. And therefore, your answer has to be this. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone got the answer? Everyone got the answer, boys and girls?
Yes, sir.
This one, give me the answer, fatafat. I don't have time. The time period of a pendulum is doubled when? When is it doubled? No idea.
Option C, sir.
Option C, sir. Thank God, sir. We know, we remember this, sir. Yes or no, sir?
Yes,
Chalo,
sir.
sir. Next question, sir. This one, sir. Please, sir, give me the answer, sir. Question number 6, sir. More the number of questions we do, sir, the better we become, sir. Yes, sir. No, sir. Answer? No one has the answer, sir. The length of a simple pendulum is increased by 1%. What will be the effect on the time period, sir? Answer, sir? Nothing, sir. I don't know, sir. That is why it is useful to do questions, sir. Else we forget, sir. Because the only thing that we should forget is the habit of forgetting things. But that is the only thing that we don't forget, and we keep on forgetting things. Yes.
Sir, wait for 1 minute, sir.
It should not take 1 minute.
Sir, option A.
Option A. After 5 minutes of discussion, we land up with option A. Great. Well done. That is the correct answer. Because we have already forgotten all these formulas we had written. That is useless. All these formulas are useless. I don't know what we were doing. We had to just divide 1 by 2. And to divide 1 by 2, we have taken 5 minutes. The answer is 0.5%, my dear friend, and I would not elaborate much on this because it's just the formula you had to apply and you could not apply it. So shame on you. You should have done better. I have high regards from you students, but when you do things like this, I really get very dejected. Do you remember that formula that we written? How does time period change when length changes? Anyone remembers it? That is the only thing that you should forget is the habit of forgetting. You write things, but you don't understand what you are writing. So please do not write anything at all. Do not write anything at all. It's of no use if you don't understand it and can't use it. Are you getting my point, beta? Everyone getting my point? What I'm saying here?
Yes, sir.
There is no point of writing things that you have not understood. What are you writing? In which language are you writing? If you are not able to understand English, throw English out of the window into the dustbin over there outside. Don't write anything in English if you don't understand it in that language. It's an alien language. Forget about that. Write in your language that you understand. If you don't understand, ask me. I will try to make you understand in whatever language I know. And please write in your language. I don't think you understand English, and that I don't know what you write and what you understand out of that writing. Because you just copy everything. Write it in your own language. The length of the pendulum is increased by 1%. Its time period 1 by 2. Increased by 0.5%. That is what you had to do. Nothing else. Okay. That takes us to the next problem. Sorry. What about this one? The a simple pendulum is executing a SHM with a time period t. If the length of the pendulum is increased by 20%, 21%, what is the percentage increase in the time period of the pendulum? Now, I will not waste much time because there is no point of giving you time on this. The formula that we had seen, this formula, the change in time period, that is half of change in length in percentage. Now remember, this formula is valid only for small change, 1%, 2%. This formula is only valid for small change. All these formulas that we get for percentage change, they're only valid for small changes. They're not valid for large changes. Because for large changes, we have applied here derivatives and approximation. They are only valid when the changes are small. When the changes are not small, you have to use the original formula. What is the original formula? T2 by T1 will be equal to root over L2 by L1. This is the original formula. Now, the length has increased by 21%. So the new length becomes 1.21 L divided by the original length is L. Are we understanding what are we doing here?
Yes, sir.
Remember, whenever we have these formulas, whether we made it for, remember, variation of G in height, the original formula was something. And then for small height, we had a shortcut formula. We remember this? Only valid for small. For original one, we have to do this. Original formula, so root over 1.21, root over 1.21, and that is what we given at 21 is 1.1. So my T2 is 1.1 times T1. So it is 1 plus 0.1 times T1. The original time period was T1 and the new time period is 1.1 T1. So how much has it changed? It has increased by 0.1 times T1, and 0.1 times T1 is 10% of T1, and therefore the increase in the time period is 10%. Do we understand this?
Yes, sir.
That is how it has to be calculated. If the percentages are large, it has to be calculated in this way.
Sir,
Yes.
the change is small means up to what is the
1%.
range of that change, sir?
1%, 2%, 3%, up till that range. 1, 2, 3%. Okay. If it is the length has become twice, length has become thrice, length has become half, you cannot apply that percentage change wala formula. Do we understand this? 1% to 3%, 4%, you can apply that formula. Okay. We understand this? We understand this?
Yes, sir.
Okay. Move on to the next question. Do it fast so that I can do whatever questions I want to do, because SHM has to finish today. This one. The mass and diameter of a planet, we just now finished gravitation. The mass and diameter of a planet are twice as that of Earth. The time period of oscillation of a pendulum on this planet, it is a seconds pendulum on Earth. Remember, seconds pendulum on Earth, time period is 2 seconds, 2 seconds, 2 seconds, 2 seconds, 2 seconds. I'll give you 2 minutes to recollect what we had done. And I hope that you can give me an answer, else I won't be very disappointed in this question. I was very disappointed in that 1% question. I'll give you time, 2 minutes. Okay, so how are we supposed to do this? We know that acceleration due to gravity is gm by r square. directly proportional to m, inversely proportional to r square. On Earth, it is the value of g is g, mass of Earth is m, radius of Earth is r. On that planet, it is g dash, g into mass is 2m, radius is 2r. So you can find out the ratio of g and g dash. G dash is g divided by 2. Now I can write t dash divided by t, time period on that planet divided by t will be equal to inverse ratio g divided by g dash. So I can have t dash divided by t is g divided by g dash is root 2. So now I have the final answer. T dash, the time period on that will be t, the time period on Earth, 2 multiplied by root 2, and that is the answer, my dear friend, 2 root 2 seconds. This is how we should have done this. I'll give you 2 minutes to note it down. Let me know once you are done. If you have any doubts, please ask. Then we come to this question. Question number, I have forgotten the number, I call it 7. A simple pendulum is suspended from the ceiling of a lift. When the lift is at rest, the time period is capital T. With what acceleration should the lift be accelerated? Upwards. So they have given that it is upwards. In order to reduce the time period to T by 2. Original time period is T seconds. We have to reduce the time period to T by 2 seconds. You have 2 minutes to give me the answer for this one. You know how to do this, yes or no? Do we know how to do this, or shall I do it? Okay, so I'll do it. You don't know how to do it? Tell me so. Okay, I don't think you know it. So how are you supposed to do this? It is in a lift. And the lift is accelerating upwards. So how do I find the time period?
Sir, acceleration is 3 times of g, sir.
Right? See, you have the answer. I was about to solve the question. That is correct. Acceleration is 3 times g. I forgot what I was telling you. Yes, I was looking for the formula of time period. 2 pi root over L by G effective. Remember, we have to finish this topic here, so we cannot just waste time. If you don't know how to do it, let me know so that I can do it, so that I can finish this topic. I have to do it today. L by G effective. Now G uh, lift is moving upwards, so G effective becomes G by A. So the original time period, if I write the original time period, T pi 2 pi root over L by G. The new time period, if I write T dash 2 pi root over L by G plus A, and this T dash should be equal to T by 2 because it has to become half. So now I can divide the two equation. When I divide the two equation, I will get this equation, I guess. 2 will be equal to root over G plus A by G. From here, you can calculate and get the value of acceleration as 3g. Everyone got this, yes or no?
Yes, sir.
Okay, good. One more question on this so that all types of questions are covered. Let's see if you can get me the answer for this one. Simple question. A simple pendulum of length L having a bob of mass m is doing angular SHM inside water. A constant buoyant force equal to half the weight of the bob is acting on the ball. So this question is just framed in a different way. Find the time period of oscillations. I'll give you 2 minutes to do this. Not more than 2 minutes. After 2 minutes, I will solve it. So how are you supposed to do this?
At least 2 by.
So you basically have to find out the effective value of G. So that will be G. You can remember this formula if you want. G minus the buoyant force divided by mass. You can just remember it this way if it is easier for you to remember. For buoyant force, you can use this formula. I forgot to give you. You can use this formula. Not a problem. So now I can find out the effective value of G. What is the effective value of G that you are going to get, my dear friends? G effective will be equal to G
By 2.
G by 2. It's going to come. Life tests your patience, but you must still remain patient. Patience is the key for life. So I get the value of G effective. I put the values and I get it as G by 2. Now I can write time period is 2 pi root over, my dear friends, L by G effective. That is the answer, 2 pi root over 2L by G. Do we understand this, or this has gone above our head saying bye bye, sir, bye bye? We are going, sir, bye bye, bye bye, bye bye. So many bye byes. We understand this? Huh?
Yes, sir.
Okay, sir. So we come to the next heading, one of the last heading of SHM. That is known as compound pendulum or physical pendulum. So that is the heading that we are going to write, compound pendulum. Or you can also call it as physical pendulum. Up till now, you have a bob attached to a string, and that was doing dung 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 dung. Now, instead of dung 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 dung, we have a body now doing pung 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 pung. What do you mean by body? So you will have, instead of a bob, you will have a body, a rigid body doing dung 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 dung. Do you understand this rigid body? So it could be of any shape, and obviously we are not going to hang it from a center of mass. You can see this point G. G is the center of mass. Do you see this? Yes or no? This is the center of mass of the body, but what we have done here is we have pivoted it about some other point. Let me call this point as O. This body is pivoted about the point O, which is not a center of mass. Do we understand this? First listen. Please don't copy everything. You don't understand what you copy. Please listen to what I'm saying. Then you write. I know you are good at Xeroxing. Wait. Understand, then write. You understand what I'm saying here? G is the center of mass or gravity, and O is the point where it is hinged. Do we understand this?
Yes, sir.
Now, please listen better, because the point is not drawing it. If you don't understand, there's no point of drawing it. Now what do? It is hung like this. I just remember this is a solid body. It could be a rod. I just disturb it from its equilibrium position. So what will happen? If this amplitude is small, it will go dung 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 like this. Do we understand this?
Yes, sir.
See this body. See, the center of mass is somewhere here, and I've hung it from this point. You can see this, my hand. See, I've hung it like this. This is the point where it is hung. This, see, dung 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 dung. This is known as what? Not dung 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 dung. This is known as your physical pendulum. So this is how I've hung it. Okay. Obviously, I cannot hang it by the center of mass because then there will be no restoring torque. So I am not going to hang it by the center of mass. Where is this gentleman? I will not hang it by the center of mass. I will hang it by some other point. We understand this?
Yes, sir.
So as soon as I hang it, the weight of the body will try to create a torque and try to bring it back to its original position. Yes or no?
Yes, sir.
This type of, if the amplitudes are small, we can prove that these motions are simple harmonic in nature. Do we understand this? This L is the distance between the center of mass and the point about which the body is hung. I naught, I naught, I naught is the moment of inertia of this body about the center of mass, or ICM, and this I is the moment of inertia about this point where it is rotating. Do we understand this? Yes or no? No, yes. Huh?
Yes, sir.
But this is what you have to understand. Then it can be proved that this motion is going to be simple harmonic. I am not going to prove it. You just have to remember the omega for this and omega for this. How will you get the omega for this? In that case, it was, in the case of linear SHM, it was root over k by m. Yes or no? Here it is, root over
L by I.
c by I. Yes or no? C was the torsional constant, torque. Okay, let's just not write it this way. So basically, what is going to happen is the weight is going to create the torque. The weight is going to create the torque. Do we understand this? So you can write this omega or omega square as the torque created by the weight will be mg into L. You can see mg into L. The torque created by the weight will be mgl divided by moment of inertia about the axis of rotation. Do we understand this I? This I is same as that I. So your omega becomes root over mgl by I, where I is the moment of inertia about the axis about which it is pivoted. Time period of pendulum will become 2 pi root over I upon mgl. Is it clear to everyone, my dear friends? How this is done? How we have achieved this? Yes or no? Huh?
Yes, sir.
Okay. Now we can see different variations of the same thing. Okay. You want to note it down? Have you noted it down? Everything? I'll give you 2 minutes to note it down. Note it down. Once you are done, please let me know. If there's anything that you have not understood, please let me know. Now you can write this same formula in different ways. Now remember, and please remember it nicely. This can be written as I naught plus ml square divided by mgl. We all understand this? Where I naught is the moment of inertia about your center of mass axis. So I can write this in this form also. This can be written as mk square plus ml square divided by mgl, where k becomes the radius of gyration. Do we remember radius of gyration?
Yes, sir.
This m will get cancelled, and I can have one more way of writing this. T is equal to 2 pi root over. Now remember how I'm writing this. K square by L plus L divided by G. Do we understand this? How I've written this? K square by L plus L by G. Do we understand this? How I've written this? Now, once I write it in this fashion, I can now write it like this. T is equal to 2 pi root over L effective by G, where this L effective becomes the effective length of the physical pendulum if we take physical pendulum as a simple pendulum. Do we understand this? K square by L plus L. This becomes the effective length of the physical pendulum. Has everyone noted this down? Yes or no? No, yes. Do we understand this? Yes or no? No, yes. No one is saying anything. Okay. Now, there are two things that you must remember here. For maximum T, for maximum time period T, your length should be 0. And T max, maximum time period becomes infinite. Length becoming 0 becomes, you tie it, you pivot it at the center of mass, it will not oscillate. The time period becomes infinite. That is T max. For minimum T, and you can differentiate this equation and find out for minimum T, how will you find out the minimum T? dt by dl will be equal to 0. From there you will get L equal to K. Very important result. L is equal to K. At L is equal to K, you get the minimum time period. At L is equal to K, you get the minimum time period. And the minimum time period is equal to 2 pi root over 2K by G. A very, 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 very important result. So I hope I have emphasized the importance enough for you to understand how big this result is, and that can easily make a hell lot of a difference if this question comes. And this is a very important graph between time period and L, where you have hung that, and you can see the minimum time period 2 pi root over 2K by G. I'll give you 2 minutes to understand this and note this down. 2 minutes you have. Well, then what we can do ahead is we can take some examples and we can just write them as standard result. The first case would be if I have, again there are infinite cases possible, I cannot write all those cases. If I have a rod of length L and mass M and it is pivoted about one of the ends, it is pivoted about one of the ends. Remember, the time period does not depend on the mass of the rod. If there is a rod of length L and mass M pivoted about one of its ends, can you tell me what will be the time period of this? Can you tell me what will be the time period of this rod which is pivoted about one of its ends? How do you get this? I've given you all the possible variations of the formula, bacha. I've given you all the possible variations of the formula, bacha. I have given you all the possible variations of the formula. Can you tell me what will be the answer? 1 minute I'll give you, not more than that. No one has an answer, it seems. So the answer for this one is 2 pi root over how much? 2L by 3G. How did you get 2L by 3G? Remember the weight of this block, weight of this rod is acting at a distance of L by 2. How did I get this time period? Time period is 2 pi root over moment of inertia divided by mg into distance between these 2 points. It is L by 2. How much is the moment of inertia about this axis? Everyone knows it. If you don't know it, well, you can go and check it out. And that is how you will get the answer for this one. I hope I have made my point pretty clear. Yes or no? No, yes. I'll give you one more chance to redeem yourself. I always believe that students are like cash cards. Sometimes they might not be redeemed because the code is wrong. I'll give you one more chance to redeem yourself. You have a ring now. Case number 2, you have a ring. You have a ring now attached to the highest point, hinged about the highest point. The top of the ring is hinged. The radius of the ring is R. Can you tell me the time period of this one? My dear friends, what will be the time period of this ring? Eh? No idea?
Sir, it is 2 pi under root 2r by g.
Well done. That is the correct answer. Again, applying the same concept. Nothing else. You have to find the moment of inertia and divide it by m into g into distance between the center of mass and the hinge point. Do we understand this? Yes or no? No, yes.
Understood, sir.
I'll give you again one more chance to redeem yourself. The rest of the ones, the rest of the cash cards. Redeem yourself. Cash card means students. Redeem yourself. Redeem yourself. Sale has come. Redeem yourself. Redeem your cash vouchers now. Last chance of redemption. Now you have disc. Last chance for redemption. Can you redeem your cash cards, cash vouchers? Notebandi. Take out your cash vouchers and redeem them now. What is the answer for this one? Eh? Has anyone
Sir,
redeemed?
T
Yes.
equals to 2 pi under root 3r by 2g, sir.
Only one voucher is getting redeemed. The rest of the vouchers are still sitting. The moment of inertia is 3 by 2 mr square. Distance is r. And therefore, we have this revolutionary answer. Do we understand this or this has gone above our heads? Saying bye-bye.
Understood, sir.
One more chance of redemption. Extended weekend. Oops. What has happened here? Sometimes things happen. You need to stay patient. And if you are patient enough, things will turn up. So one more chance that you are getting for redemption, my dear friends. Redemption, redemption. Cash voucher redemption. This one, question number 3. Redeem your vouchers now. Redeem your vouchers. Voucher redemption. A disk is made to oscillate about a horizontal axis passing through midpoint of its radius. Midpoint of its radius. What is the time period? Midpoint of this radius, my dear friends. Redeem your vouchers fast.
Sir, it is also
It is also time period is 2 pi root over. You can do it by I by mgl or mg into the distance, or you can just I mean, if you can remember this formula, I think it is better to use this formula, k square by l plus l divided by g. Yes or no? I think this is better to use this. Yes or no? So I just have to find the value of k square by l plus l. What is k square for this? What is k square for this? It is r square by 2. Yes or no?
yes, sir.
The distance is r by 2. Yes or no?
Yes, sir.
Plus the distance is r by 2. So whatever you get is the answer. 3r by 2 I think you are getting. Yes or no?
Yes, sir.
Trust, keep faith on yourself that if you are getting this, this has to be the correct answer. Do we understand this? Yes or no? No, yes.
Yes, sir.
So this is the answer. One more question. Again, the scheme has been extended. The scheme has been extended. One more chance for redemption. One more chance. One more chance you are getting.
Sir, once you do it by that I,
Yes.
sir, once if we do it by I,
Same same thing you will get. No matter what. You find the moment of inertia about that point. Same thing. From that moment of inertia only we derive that relation. Will not be any different. It will not be any different. You will get the same answer no matter what. We derive the relation by the moment of inertia. You will get the same answer. Moment of inertia will be mr square by 2 plus m into r by 2 ka whole square. You divide it by r by 2. Same thing you will get no matter how you do it. Do you understand this? It will not be a different result. It cannot be a different result. Okay, we got this.
yes, sir.
Comes the next question. I'll give you 2 minutes to solve this. A rod with rectangular cross section oscillates about an horizontal axis passing through one of its ends, and it behaves like a second pendulum. Find the length. It's a simple thing. I'll give you 2 minutes to solve this. So how are we supposed to do this? I can't give you more time because we are short on time. How are we supposed to do this? So we know time period is 2 pi root over k square by L plus L divided by G. Yes or no?
Yes, sir.
And this time period is same as second pendulum. Time period of second pendulum is 2. So 2 is equal to 2 pi root over k square by L plus L divided by G. Yes or no? 2 say 2 will get cancelled. And remember, you can also cancel pi square with pi. So if I square these two equations, one will be equal to pi square divided by G into k square by L plus L. And remember a very important result, pi square is approximately equal to G. Pi square is,
Yes, sir.
remember this. So now we have k square upon L plus L is equal to 1. K square is, k square for this is L square by 12. Yes or no?
Yes, sir.
into L is L by 2. Remember, this L is not that length of the rod, it is the distance of the point, right?
Yes, sir.
So L square by 12 into L by 2 plus L by 2, that must be equal to 1. So from here you can find out L say L go on L by 6 plus L by 2 is equal to 1. Yes or no?
Yes, sir.
So how much you are getting LS? This is 6. 4L by 6 is equal to 1. Yes or no?
Yes, sir.
So 6 by 4, 3 by 2, L will be equal to 3 by 2 meters. That is the answer that we were looking at. Do we understand this, or this has gone above our head saying bye bye, sir? I am not coming back, sir. Do we understand this?
Yes, sir.
Okay, na, sir?
Yes, sir.
Okay. Now, remember, there are some very standard cases of SHM. So I will now give you the list, and you have to draw the diagram and note down the standard cases. Standard cases of SHM. You might get one of these standard cases in your examination. So just remember these standard cases of SHM. The first of this case is SHM of a liquid in a YouTube. So what you do is, you understand YouTube? It's not YouTube where you post videos. That's not the YouTube. It's a tube which is U in shape, and then you have this liquid filled to a height h, and we displace the liquid. Remember, the time period of this displaced liquid is 2 pi root over h by g. 2 pi root over h by g. Just have to draw the diagram, write the answer, and stay happy. SHM of liquid in a YouTube, all these things you must note down very, very carefully. Have you noted it down?
1 minute.
Note it down? Note it down fast. Should not take so much of time. Just draw YouTube and put what liquid. You don't have to note down the entire Ramayana. Who is Ram? Who is Lakshman? Who is Sita ji? No. You just have to concentrate on the Ravana. The Ravana is the time period. That's it. That's the only thing that we are concerned about. Do not write all these things. Just draw the diagram. Just draw the diagram and write the result. 2 pi root over h by g. Have you written this? Chalo, we'll move on to the next one. I don't have time. I can't wait so much for your drawings to happen. Okay. And now don't note down. I'll put 3 or 4 diagrams here. Then you note down. The next one is case number 2 is the SHM of a floating cylinder. So what they have done is they have a cylinder. First, listen to me. I'll give you time to write. They have a cylinder like this. and it is floating in a liquid like this. The time period is 2 pi root over L by G, where what is this L? L is the length initially inside the liquid. Just wait, I will give 3 or 4 cases in one sheet so you can do them together. Then the next case is SHM of a ball which is rolling in a hemispherical bowl. So you have a hemispherical bowl of radius r, and you have a small ball, green ball of radius small r. The time period of SHM in this case is given by this formula. The next case is the case of a bar magnet. It can be a bar magnet, or it could be an electric dipole in a electric field. We don't know these terms, but you can just note down. I is the moment of inertia. M is known as the magnetic moment, and B is the value of magnetic field. So you hang this and it starts, and if you give it a small twist, it will start to execute simple harmonic motion. That is number 3. And I'll put one more, which is number 4, which is for SHM in a air chamber. SHM of a ball in a air chamber. Now remember, we don't know terms in this. I understand this, but you just note down the results. SHM of a ball in the neck of an air chamber, 2 pi by A. A is the area of cross section of the neck. This is the neck. M is the mass of the ball. V is the volume of the air chamber, the total volume. The only thing that is new is E is known as bulk modulus. Bulk modulus of air. Now I'll give you 5 minutes. Please note them down. Let me know once you are done. Everyone can see the diagrams, yes or no? Everyone can see the diagrams, yes or no?
Yes, sir.
Okay, note it down. Then we come to these cases. This is case number 5. Now this is the case of SHM of a body suspended from a wire. The body suspended from a wire, elastic wire, is same as body suspended from a spring. It is same as root over 2 pi root over m by k. This case, in this case, becomes YA by L, where what is Y? Y is the Young's modulus. You may not have heard about this word. A is the area of cross section, and L is the length of the wire. This is case number 5, same as spring. We will come when we get time. We will come to this and we will get this. 6th one is the SHM of a piston in a cylinder. M is the mass of the piston, A is the area of cross section, H is the height of the cylinder, and P is the pressure in the cylinder. Just remember this formula. Then the next one is 7th one. This is the SHM of a cubical block. You have a cubical block, you apply shear stress force on the upper side, and then it will oscillate like this. Do you understand how it is oscillating? You understand how it is oscillating? See, the block is like this, and I apply a force like this, so it oscillates like this. Do we understand? That is cubical block. 8th number is conical pendulum. I've already told you about conical pendulum. This is the formula for conical pendulum. I'll give you 2 minutes, 3 minutes to note them down. Any one of this will come as a straightforward question, so remember this. Then we have the last 3 cases, 2 of them of the similar nature. In case number 1, you have SHM of a tunnel dug through any chord of earth. The answer is 2 pi root over r by g. In the next case, we have a tunnel dug to the center of Earth or diameter of Earth. The answer is same. So no matter how you dug the tunnel, the answer is same. The last one is RC LC circuit, which will be coming sometime after one. The time period of SHM of this LC circuit, L is the inductance and C is the capacitance, is 2 pi root over LC. I'll give you 2 minutes to note it down. We have seen these 11 cases of SHM apart from all those different cases. Now remember, we'll have to remember these results. We cannot prove this SHM because in most of the cases, these are coming from topics that we have not already done. Anyways, how to prove it, I have already told you how to prove it. We can prove it by the force method or the energy method. Now, I've told you the force method. There is a energy method as well that can help us in solving problems and proving that it is a SHM. Now, one thing is left that is known as the superposition of SHM. Now, we don't have enough time to do that part because time is not enough to do it.
Done, sir.
So what would we do is I'll give you one or two questions based on what we have. One question based on this. Okay, this is done. This is done. Superposition of SHM we will do in the next class because that will also be a what be a revision of we will be continuing with the same thing in the next chapter, which is wave. So let me put this question just to just to understand whether we have understood the concept of SHM or not. Remember the cases that I have given, they may come, they may not come. This is like cases from all the physics. From this topic of SHM, these are the type of question that are going to come. Block of mass M2 is in equilibrium position. Another block M1 is placed gently. What is the time period of oscillation? And what will be the amplitude of oscillation? These are the type of question that you are supposed to know. What is the answer for this one? What is the time period of oscillation? What will be the time period of oscillation? It will be simply equal to 2 pi root over M1 plus M2 divided by K. Do we remember this?
Sir.
And what will be the amplitude of oscillation? We've done the same question before. It will be equal to M1G by K. Do we remember this? We have done the same question before. I have just put the same question. We have done the same question. It seems like ages before, but it was not ages before. It was yesterday's class only. This class we have covered a lot of things. I understand, and that might be The reason that it's difficult to recollect. See, this was the question that we did. In this question, M1 was removed from here, and then we found out the oscillation. Do we understand this?
Yes, sir.
So this question is just the reverse of it. Here, since the block is in equilibrium, I put one more block on the top of it. So it's just the reverse of it, nothing else. Do we understand this?
Yes, sir.
So the same question comes here with the same answer. The amplitude of oscillation is M1G by K. So we understand this?
Yes, sir.
Okay. Okay, then that brings us to an end of today's class. We have covered a lot of portion in today's class. We have covered, actually, if I see in one way, we have covered the entire SHM literally in one class. We've done all types of questions that are possible. The only types of questions that are remaining are superposition of SHM. It will take some time because I just don't want to rush it, because the same thing we have to do it in waves. So with superposition of SHM, we will start with waves, so that portion we can take it in the portion of waves also. I mean, because the same thing, it's exactly the similar thing. So we will do that in the next class, that is tomorrow.
Sir, is there any worksheet for SHM?
Is there any worksheet for SHM? There is worksheet for SHM, and I'll send you that worksheet. I forgot to send it. I mean, I'd sent so many of them, I forgot. So what I'll do is I'll send you that one. I will send you worksheet of SHM and waves together. Okay.
Sir, and for gravitation also?
Gravitation also I have not sent.
No, sir.
Okay, I'll send all the three today. Okay. Anything else?
Okay, sir. No, nothing, sir.
Okay. Chalo then. I'll see you tomorrow. I'll send the worksheet by evening today. Okay.
Thank you,
Bye
sir.
bye.
Have a good day.
God bless you. And please work harder, beta. I'm expecting a lot from you, and if you give me stupid answers, I just get mad. Okay. I hope you understand it. Take care, and God bless all of you. Bye bye.
Bye, sir.